Hi everyone. In this video, I will continue the discussion on STKO software. And if you haven't watched the previous video series, then I must recommend you to watch the previous video series because these lectures are interconnected to each other. So, just in case if you missed one lecture, then you will find it difficult to continue from this current lecture. So, in the previous lectures, I discussed about the preprocessor and post-processor modules. I discussed about all these options that are available in STKO. I discussed about all these options. I discussed about all these options, and you can find it in a very detailed way in the previous videos that I mentioned. Um, So I also discussed about these options. Um, I also discussed about these options, and I also discussed not in detail about the definition. Uh, Also, I did some discussion on these options for physical properties, and I also did some discussion on it. And similarly, I discussed these as well. One thing I want to remind you again is I mentioned these three options that are present here: the definition, physical properties, and element properties. These are the backbone of the STKO. And just in case if you haven't uh, learn about OpenSees by studying these three terms in detail will give you more than enough knowledge about the STKO. So these options that are available here are solely dependent on the OpenSees knowledge. If you have no experience on OpenSeas, then these three options will not give you any benefit in that case. Other than that, now I'm switching to the conditions in this lecture series, and then I will discuss about the mesh. So before that, let's create a geometry offline, right? So for example, I have a point. This is this one, and then I have a point 0, 0, 100. Then I have next point 100, 0, 100, and press enter. And then I have next point 100, 0, 0. So I created this portal frame. Let's switch off this grid option here, and let's quickly discuss that what exactly are the conditions. So let's rename it and call it photo frame. I also want to express the expression format that you should follow. It's very professional way to consider in programming language. So, according to the current lecture, now we are discussing about the conditions in the lecture series. So previously, I discussed the work plane. I also discussed the local axis. I also discussed the selection sets. I also discussed the geometries, and I even discussed the instructions. So now I am at definitions, so the conditions here at this point, and these three options are left for a detailed discussion in the coming video series. So for the definitions, physical properties, and element properties, these three options will be covered in the detailed way. At current stage, I'll recommend you to follow this lecture series the way I'm doing it because with one attempt, um, a, a proper understanding will be obtained here, and then we can further discuss and deep dive into the discussion in this software. So we are at conditions, and if we look at the region here, we understand this from the notation with what it represents here. So basically, conditions are referred here to the boundary conditions that are constraints and the loads, etc., that cause the actions and reaction statement and make the the system sorry, and bring the system in equilibrium. Those factors that are related to the region here. So let's just make it more simple by creating a condition. For example, if I want to create a boundary condition here, a fixed boundary condition here, and I am doing a 3D analysis here, right? So before that, let's define that and call it fixed end, right? A fixed support of, and we can call it only a fixed support here. Anyways, um, before that, a very professional way to consider is, for example, if I go to home and make it more sensible. So let's switch off these options and only left the vertex command and call it uh, node A, right? And similarly, by doing again, call it, sorry, call it, I'm sorry, new, and select this one, press enter, call it node B, right? Click on OK. And we got this here. So let's just delete this one, right? This node thing is very annoying sometimes because the problem is these tags are automatic, and that's why it's making trouble for us. Anyways, the this is node B, and um, if I create another point right here and call it node C, and create another point selection set, sorry, and call it node D here. So now it makes sense here. I have these four nodes that are present in my model. This is node number first, sorry, node A, node B, C, and D. So look at here, node A, node B, node C, and node D. So these are the nodes, and I have this focal frame here in this OpenSees, sorry, STKO environment. So just in case if I am interested in assigning a boundary condition to this region here, so I have to go to this region and call it uh, fixed boundary condition, and I'll call it node A, right? And even you can cover the colors that you want to consider here. I don't want to change this here, um, and I will apply a constraint here. So I will in detail discuss these one by one, but at this stage I only want to assign a fixed constraint here. So I want it to be 3D UX UI UZ, and I want to make it uh, uh, this way, in this way. So this one is only pen connection. This one is with consideration of pen and this pressure, and this one is consideration of displacement and rotation here. So if you have any doubts, you can visit to the fix command in OpenSees as well. This is the documentation according to the OpenSees the command manual, and in this documentation, you will find out a discussion on the commands that are associated with this region here. So if you are writing an OpenSees command, sorry, an OpenSees file here, and you want to include the command to construct a single point homogeneous boundary constraint, then the first thing that you should be careful about is the node tag, right? And the second one is the constraint value here. So a node tag should be integer tag identifying the node to be constrained. And if you are using STKO, these tags are automatically assigned to it. Like just you can see here, these are the tags that are assigned to it. So this is an integer value. Constraint value that you are using here uh, is this one. N degree of freedom, constraint value 0 or 1, corresponding to the n degree of freedom. If it is 0, it means it is free. If it is 1, it means it is fixed here. So OpenSeas will automatically make it fixed if you assign boundary conditions in the direction here. There's kind of a, sorry, STKO, and it is kind of a binary operation here. If you are using a zero value here, it means that you are unchecking this one. If you are using a tick value, it means it is constrained and it is a one value here. So according to the OpenSeas documentation, if you make it OpenSeas, STKO a fixed node here, so it will be fully fixed here, just like the way I considered here. But if I want to make it homogeneous constraint and I want to allow movement in one direction for degree of freedom 2 and 5 only, then it will be the non-homogeneous constraint here. So for example, if I want to allow in y direction the moment and I have uh, some spring element here which I want to assign at this node, it is basically node number A, then I should be very careful about this boundary condition and I should avoid assigning one value to this region in the background, just like the way I showed here and explained it here. So according to OpenSeas, if it is 0, it is unconstrained. If it is 1, it is constrained. And according to STKO, if it is checked, it is 1 and it is constrained. If it is 0, it is unchecked and it is unconstrained here. So be careful about this notation here. Um, so we selected this and we don't need to apply any filter here, uh, and done. So now remember here, according to the notation that I mentioned previously, if it is gray, it means it is not assigned, right? So we can do something like this. Either we can right click on the open STKO modeling tree environment here and click on edit to edit it, or I can also visit here, and after that I can click on edit here, and this way I can do it in this manner. So in either way, it's not yet assigned because I did not select the node here. So in order to assign it here, I should be in the condition editor module right here in this pop-up window, and I should select the node, the region to which I want to assign this. So now I selected here and it is red now, so it is fully selected. And when I click on OK, this condition will be assigned and we will see the color changing here as well. So as soon as I click on OK, this is assigned now and the color is changed here. You can see the color. So it is now assigned in the fixed boundary condition constraint here, right? So this is constraint.sp.fixed. So it is in constraint category and it is a SP category and it is fixed here, right? So I will try to make a detailed video series on these OpenSeas language constraints, OpenSeas language notations as well in this way. Anyways, let's go to this second one and let's go to uh, create a new one. We can clone it here as well. From this, we can take a clone and edit it, and we can assign a vertical roller here only. So U by and UZ. Uh, it can, let's make it vertical roll. Let's make it a pin connection here. So if it is fin, it means UX as restraint. Let's remove it and call it horizontal roller, and it is at node B, right? So now it makes sense, and um, after that go to edit and then select this one, cancel it, and go to edit. I'm sorry. At current stage, I think we should select control to unselect it, like here, and we should select shift to select it here. So I did this, so I need to go to this command here, and currently I am in this region, so I should select control and I should select shift here. But again, those signs are present here, so we should be careful about it. Now it is selected here, and click on OK. So this roller condition, sorry, this condition is assigned to this region as well now. So we have assigned these two only conditions here, the first one and the second one. If I want to apply a horizontal load, right? Horizontal load, and we can call it horizontal P. It is a concentrated load, and then after that, it is to be on node B. So in that case, I will select the loads and force, and we have this H force command here. So orientation is global. Do not assign any local axis to it, and select on this and look at the x-axis here. So I want to make it 10 at this point only, and then I need to select this one. Sorry, here. Go to edit, and after editing, I'm sorry. If I want to apply a constant push here because it is an edge load, um, so for edge load, we generally get this. So if I want to let me convert it to nodal force, then it will be no problem for us. I'm sorry. And 100 because I cannot select a surface here, a node based on the surface here. So click on OK, and then again click on OK. So now you can see I have assigned an edge load here in this direction, right? So now it's assigned in this way. Let's define a new load here and call it but before that, it's a good way that you should select the you should do the definition of the elements as well to make it more sensible for yourself. But I will avoid it at this point. Anyways, if you want to uh, do this, then you can select this and press enter and call it member AB, right? And if you want to add another one, then you can call it member BC, right? And if you want to add another one, then you can call it member C, right? So now it will make sense here, and it's more than enough for me to understand the notations here. So and let's quickly add a UDL, right? A UDL on the member BC vertical gravitational load here. And on the loads, I will now go to the force, generic, not force for SP. I'm sorry, it will be H force, and here it is, for example, in Y direction. I'm using here so minus 100. So select this and click on OK. So now we can see here, if I show it in 3D, that we have this push on this region. So just in case if you want to, now it is in Y direction, and this one is Z direction here. So if I want to convert it to that direction, then let's make it minus 100 for vertical direction here and click on OK. So now I converted it to this way, right? And you can explore further by assigning a support settlement. If you want to do a support settlement in all these stuff here, you can do it. If you want to delete the boundary condition or the conditions here, you can click on delete and select it and then do whatever you want with it. For clone, I already demonstrated that with cloning, you will get a copy of the condition here. And with editing, you will get editing of the boundary conditions or the conditions that you have defined here. So then you can do it and you can switch from one to another option. But make sure if you are editing it here, for example, if I consider this node here, then your choice must make sense in terms of selection of the criteria. For example, if you are selecting an edge load, just like the way I showed here, and you are assigning it to a point, then it will not give you an accurate result. And not you will not even be able to select that point because in STKO environment you cannot do that. And if you want to assign a fixed boundary condition to a node and you are selecting another region, then it will not create any sensible results for you. If you want to consider a ground motion data, for example, then you should select a choice that is making sense for you and your criteria other than just going to define it here. So I try to include these options one by one in a detailed way before going into a further discussion on this criteria here in this way. So the thing is, you should try to understand these process in a detailed way before going into just assumptions and assigning it in the HTTO environment. Because in the backend, OpenSees is involved and there are some limitations in the criteria. So it's very tricky. Anyways, thank you so much for watching. Have a good day.